find the maximum and minimum values of this function 2xyz on the ellipsoid x square plus 2y square plus 3z square equals 6. This is the constraint, by the way. So we need to make right hand side 0 or just leave constant. So whatever we have here, this is g with -6 or without -6. It doesn't make any difference. So here the constraint, from constraint we can create this function x square plus 2y square plus 3z square minus 6. Now to use Lagrange multipliers method, we need to find gradient of f, del f, and just fx, fy, fg, which is, let's find partial derivative with respect to x, that's 2yg, partial with respect to y, 2xg, and partial with respect to g, so 2xy. Similarly, we find del g, gx, gy, gz, which is with respect to x, 2x, with respect to y, 4y, and with respect to g, 6g. Then we use the following using the Lagrange multipliers. Del f equals lambda del g, which is in fact 2yg, 2xg, 2xy equals lambda times this 2x, 4y, 6g. So from this we get three equations. 2xyg equals, 2yg equals lambda 2x, 2xg equals lambda 4y, and 2xy equals lambda 6g. So we solve these three equations along with the constraint. Here is the constraint, x squared plus y, 2y squared plus 6g squared equals 6. So we need to solve these equations, solve the system of equations for x, y, g. For this, okay, we might get multiple points here, and once we have those points, we evaluate the function. Go back here and evaluate the function with these x, y, g, and the maximum is the biggest is the maximum and the smallest will be the minimum. Okay, let's solve this. Okay, we need to we can always isolate lambda from here. Lambda is never 0, so lambda, 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 then we can get a couple of equations. Or the idea here is from the first we can get x equals something, and here we can get y equals something, and x and y and g equals something, plug in here. Okay, but if we solve for x here, that will be in terms of yg. Solve for y, xg, that does not help. Okay, so let's think how we can solve. We have yg, xg, xy kind of symmetric, x missing. If we multiply this by x, then we have 2xyz. Here we go. Then we multiply this by y, 2xyz. Multiply by g, 2xyz. So the left hand sides will be the same. That means the corresponding right hand sides will be same as well. And from there we can multiply here, because x times x, this will be only x, only y, only z, and we plug in here. Okay, so if we multiply here, so let me erase this. Once we multiply, we get 2xyz equals lambda 2x squared. From the second, 2xyz equals lambda 4y squared. From the third, 2xyz equals lambda 6g squared. Okay, since the left hand sides are equal, the right hand sides should be equal as well, and all of these got lambda, so we can get rid of lambda. That implies 2x squared equals 4y squared equals 6g squared. Okay, which is, by the way, which is same as, we can divide by 2, that is same as x squared equals 2y squared equals 3g squared. Okay, we come back here, and I copied this wrong, sorry about that. This is 3g squared. Now 2y squared is same as x squared, so replace 2y squared by x squared and 3g squared by x squared as well. Then by the constraint we get x squared plus 2y squared, which is same as x squared, plus 3g squared, which is also x squared, equals 6. That means we get 3x squared equals 6 divided by 3, 2x squared equals 2, so x equals plus minus 2 root 2. So we have x here. Okay, and from here, look at this, then we can write 2y squared equals x squared, and we can find y, and from here we can find z. So we got here 2y squared equals x squared, or 2y squared equals x squared means plus minus root 2 squared, would be always positive, just 2, and divide by 2, we get y squared equals 1. So y squared equals 1, take a square root, plus minus 1. Okay, and from the third we have to find g here. 3g squared is also x squared. 3g squared equals x squared, that is 3g squared equals 2 divided by 3, 2/3, so g equals plus minus root 2 over root 3. So thus the points are in fact plus minus root 2 comma y is plus minus 1 and plus minus root 2 over root 3. Okay, so in fact we can take all plus, all minus, this plus minus minus, okay, and this is minus plus minus, so there are in fact 6, we got 6 distinct numbers here, I mean points, because plus plus plus, minus minus minus, plus plus minus, plus minus plus, etc. Okay, there are 6 points, and we have to go back and look at the function here. We are trying to find the maximum minimum of 2xyz. If we plug in all positives, then the value will be positive, that's the maximum. And if we plug in all negatives, then negative times negative, that will be negative, and that will be the minimum. Okay, so let's do that. Or for the minimum, or for the maximum, we can take 2 negatives and 1 positive. So eventually we want to make everything positive, so 2 negatives, 1 positive also gives us positive. So anyways, the maximum, okay, max value of the function will be 2x y g root 2 over root 3, which is root 2 times 2, 4 over root 3. That's the maximum, and minimum value will be just negative. Min value is, okay, just make negative. We can take all negatives or just 1 negative, other positives. So negative 4 over root 3. Okay, so that's the max value and min value, final